Example 3.2, determine the voltage of the 1 ohm, the current of the 5 ohm, and the power of the half an amp current source. And then tell me whether it's passive or active. Okay, so what are we looking for in this calculation? So what this tells us here is that we want to calculate the voltage of the 1 ohm, which I can write as node voltages. I'm going to need the current of the 5 ohm, and I want the power of this guy right here. So in order to do that, I'm going to go through my process here. Now note the ground has been defined, so you must use this ground. So let's do the usual process. Step 1. Let's do the numbers. And that means here is that we want to determine the number of node equations to solve. So let's put in the circuit. So here's my circuit right here. So let's look at this thing. So if I start to count my number of nodes, note that this is my first node. That's the red node, which I'll label as, let's call it A. Then I'll have a green node, which I'll call B. And then I have a blue node, which I'll call C. And of course, there's a reference node. So that's one node that we already know. So when I look at this guy, I have 3 nodes minus 1 voltage source. So I got 1, 2, 3 current sources, 1 voltage source, but when I'm doing node, it's only the voltage source that matters. So now if I start to add this, this tells me that I have 2 unknown nodes. So when you're looking at this, what we're really asking, when I look at this guy, I really have to answer what kind of voltage source is this? And so when you're looking at this, and you can see here that the only voltage source is not connected to the ground, which is at 2 volts. So you're seeing that this is not connected to the ground. So if it's not connected to the ground, that means it's a supernode. A lot of times I write as SM. So if you're seeing here, so if this is a supernode, I'm going to come in now and I'm going to draw in my node. And there's my node right there. Okay, so this is my supernode between B and C. So when you look at this, you can see that the first thing that you should see here is that you note that I have a regular node. So that's the node of A. Then I have a supernode between B and C, but with every supernode, there's a supercondition between B and C. And so if I add these up, you could see that I have 3 equations. So I'm going to have 3 equations and 3 unknowns. In this case, it's going to be VA, VB, VC. That being said, let's apply node analysis to each of the unknown nodes. So here we go. Step 2. Apply node to each unknown node. So let's talk about node A. So if I look at node A, you could see that I have 2 resistors. Okay, so I have 2 resistors. So I have 1 and 2. So I'm going to go 1 plus 2. And then I'm going to call this node A. And so node A is what I'm going to label with red. And then I have the mutual. So I have minus 1/2 times VB. But note that that VB is this green node. And then I have 1 resistor connected to the grounds. So that means I have minus 1/1 times 0 volts. But we already, as we discussed already, that's going to be 0. Now I need to look at the current sources. So if I look at the red node, there's only 1 current source, and you can see that the current source is moving out. So then this is going to be 1/2, and I'm going to put in a minus sign to tell you that it's moving out of the node. Okay, so this is going to be my equation 1 here. Now let's go to the supernode. So if I look at the supernode between B and C, what do I see here? So that means I got to write 2 node equations in one solution and 1 equation. So 2 nodes in 1 equation. So here I go. So when I do this, I want you to, it looks something like this here. So I look at the node for B. So I have 2, 2 and 5. And this is going to be B. So you can see here is that B is this green. Mutuals. One with VA, and then the other one with VC. So if I look at this guy, remember this is VC, and this guy right here is VA. So this tells me all of the nodes, the node voltages connected to node B. So now let's go to the second node, which is node C, and you can see that there are 2 resistors. So I'm going to get 1/5 plus 1/4 of VC minus 1 connected to B, which will be the 1/5 VB. And then I have 1 with the ground that looks like this here. So this one right here is the one connected to node C, but of course that's 0. So now let's look at all of the sources. So if I look at all of the sources, look what I'm seeing. So I look at the nodes for B. If I look at the nodes for B, note that the 1/2 is flowing in, the 1 is flowing in. So I should get a plus here and a plus here, which then tells me that this is 1/2 plus 1. And then look at the blue node. There's 1 current source flowing in. So that means I'm going to get a plus for this guy, which will then be 2. And if I add this up, note that this guy's going to be 3.5, and that gives me that node right there. So right now I have 2 node equations here. There's something interesting that happens here. And it looks like this. I'm going to say that there's something interesting with the 5 ohm resistor. And what you're seeing here is that, let's redraw it and focus on this. So I'm gonna say, let's redraw this. So if I redraw this, here's my circuit, right? Here's my circuit right here. So what I want you to pay attention is that let's focus on the supernode. So if I look at the supernode, we agree that this guy right here is like this. And we agree that this guy's right here. So we know this is B, we know this is C, and we know that we have a supernode. So let's draw in this supernode again. Right? So this is my supernode BC. Now, what you're seeing here is that if, I'm going to say here is that see how the supernode shorts out the 5 ohm resistor. And what this does here is that it's not a physical short, but a mathematical short, a mathematical cancellation. Maybe cancellation is a better word. Cancellation in the supernode of BC here. Now, let me show you what I mean. So now what I'm going to do here is that I'm going to rewrite the equation all over again. So I'm going to come up here and I'm going to look at this node and I'm going to take everything with me. And let's modify this a little bit. So if I take the same equation, I'm going to highlight a couple of things so that you could see what I'm trying to show you. So the first thing here, I'm going to take this piece out here. I'm going to take this piece just to make it nice and clean. Now I want you to focus on a couple of things. The first thing that I want you to focus here is that everything is about that 5 ohm resistor. So look at this cancellation. There's this 5 ohm, and that's connected to this B right here, which is this guy right here. So note how that's plus a fifth, and this is minus a fifth. So you're seeing a cancellation between the fifths between VBs, and then the other one I want you to pay attention is that look at this cancellation here and here. So that resistor between B and C drops out of the whole calculation when you're looking at the mutual resistances and the primary resistances. So what this does here is that it reduces the supernode equation between B and C. So if you look at this thing, that means that this guy gets canceled out with that guy, and then this guy right here gets canceled out with that one. So the equation that you have at the end here is that you're going to get 1/2 BB minus 1/2 BA plus 1/4 BC minus 1/5 BB. Wait, that can't be right. All of the fifths should cancel out. So if I'm looking at VC, I should have, there should be nothing here. And so this guy should equal 3.5. And this is our third equation. So again, here's my B, here's my red, and here's my blue. Make sure I did that right. Yeah, I should have all of the 1/5 terms cancel out, which they do. So that's my third equation. That's what a supernode equation does. So then I'm going to look at the supercondition between B and C. And if I look at that, I look at where the voltage source is at. This is the 2 volt. Note that C is higher than B. So then I look at, so this guy tells me it's going to be VC minus VB is going to equal to 2. Once again, this is the high, this is the low, and you could see that the green is higher than the, oh, did I get my colors wrong? No, the C is the higher, so that's the blue. No, so this one's the blue, and this one's the green, and that gives me my third equation. I call this one 3, but this is really 2. So now I'm going to write this into matrix terms. Okay, so now what I'm going to do here is I'm going to take my equations and I want to sort of like look at these guys. So I have my node 1, my equation 1, which is right here. Okay, so now I should say here is that I'm gonna now write these equations into matrix form. And you've been seeing here is that I use double underscores to ID VA, VB, and VC terms. And so as I've been going along, typically I don't do that, but I was just trying to emphasize this. So let's look at this guy. So what you're seeing here is that if I clean this up just a little bit, here's my first equation. Right, here's my first equation. I'm going to call this guy 1. And you can see how I have VA right there. So now I'm going to go get this guy right here. This is the second equation. Right, here's my second equation. And then finally, here's my third equation. So now I'm going to put this into matrix form, right? So if I now put this into matrix form, now note, I would never rewrite these like this. I'm only doing this because I can do this on this tablet. But typically, I would be looking at these equations and then start writing them into this matrix form. So now if I have matrix forms, look what I got to do. I have what? I have VA terms. I have my VB terms. I have my VC terms. And now I'm just going to start looking at this. Look for the reds. Look at the red. So with that should give me 1 plus 1/2. Look at the red. It's minus 1/2. No red, so that's 0. Then I go to the blue, the green. So you can see with the green, I'm going to have my first one's going to give me 1/2. My second one is going to give me plus 1/2. And my third equation gives me 1. And then if I look at the blues, you can see the blue has 0. In equation 2, I have 1/4. In equation 3, I get 1. I have my matrix. which then tells me BA, BB, BC, and then this guy is going to be my constant terms, which means it's got to be the right side. So if I look at the right side, you can see I'm going to have what? Minus 1/2, 3.5, 2. That's my equation right there. So what I did here is that I now put this into matrix form. And so from this, I then say that I then get matrix magic. And matrix magic tells me that I'm going to have that VA is going to be 1.29 volts. VB is going to be 4.87 volts. And finally, VC is going to be 2.87 volts. So now I have my node voltages. So what we need to do though is that we need to calculate the voltage of the 1 ohm, the current of the 5 ohm, and then the power of the 1/2 amp. So let's go look at the circuit here and see what do these values mean. Okay. So when I look at this, here's what I'm saying. I have this guy. And what do I know? Well, VA is this node right here. And we know here that this, I'm going to move this over a little bit. This VA is 1.29 volts. Then I have VB. And so if I look at VB, we know that that node is 4.87 volts. And then we have VC, and that tells us that this is VC, and this guy is 2.87 volts. And of course, the bottom is the ground. So what we need to do here is that the first thing that we wanted to calculate, we need to calculate. The first one we want to calculate is the voltage of the 1 ohm. So if you look at the voltage of the 1 ohm, what this really tells us is that it has to be the voltage, which is the difference between the node voltages. And you can see here that this guy right here, from here to here, is the voltage of the 1 ohm. So it has to be the difference between VA minus the ground, which then gives us 1.29 volts for the voltage of A. So we now know what that voltage is. It was just one of the node, it's not the node voltage. Now the second thing that we need to calculate is we need the current. So the current of the 5 ohm resistor, that should be the voltage difference of the 5 ohm resistor divided by 5 ohm. But you can see here is that the high is B. So this should be VB minus VC divided by 5. So if I plug that in, look what I'm going to get. I'm going to get 4.87 minus 2.87. And then this is divided into 5. Now look what I actually see though. What you're seeing here is that I get 2 volts divided into 5 ohms, which then gives me 0.40 amps, and that's the current of the 5 ohm. Now, one of the things I want you to know here is that we already knew what the voltage of the 5 ohm, because note that it's parallel to the 2-volt source. So we knew this already. Since the 5 ohm is in parallel with the 2-volt source. So we already knew that. So now the last thing that we want to calculate is we want to calculate the power. We want the power of the 1/2 amp source. So of course that has to be the voltage of the 1/2 amp source times the current of the 1/2 amp source. So now let's look at the 1/2 amp. Look what's happening. When you look at this guy is going from where? Look at that. There's the high is VB, so this has to be VB minus VA. Once again, that's the high, that's the low. So what really determines whether a source is active or passive is the direction of the current. So now look, this guy is going from low to high. Therefore, this guy is active. So then if I multiply this out, and this guy's going to be 0.5 amps, if I multiply this out, I'm going to get, right? So I'm going to get minus, and then I get the quantity of 4.87 minus 1.29 volts times 0.5, and this will be in units of watts. So then I get a value that equals 1.79 watts would be the power of the 1/2 amp source. And again, we know that this source is active.